Hi, Dagny. Here's the answer to your question. You have, let's see, part A, z greater, the probability that z is greater than 3, so that's correct. You calculated the z stat, and then you're looking for the probability that z is greater than 3, which is to find the p-value. This is not the p-value, by the way. No, you're looking for the p-value. So here's your diagram, which is correct here. You're looking for this part, which you've shaded correctly, and I assume you've done that because the hypothesis is greater than 60, right there. So greater than is the right side. So to calculate the p-value, you're looking for this area here. And the reason we subtract 0.9987, which, by the way, you got from the table, you looked up 3.0 from the standard z table. We subtract it from here because the z table gives you areas rolling in from the right, right? So if you look at the little icon at the top of the z table, the little blue part shaded, right? Blue is the part that is the area that's given to you in the table, but you're not looking for that part. You are looking for this part, the green part, right? So since this is given from the table, to calculate the green part here, you need to say 1, which is the entire curve, 100%. That's what 1 means, 100%, minus 0.9987, and that's why you subtract, because all of this, subtracting the blue part, leaves you with the green part, which is what you're looking for, and that is the p-value. So the p-value is equal to 0.013, if you calculated that correctly, which it looks like you have. Okay, so the p-value is actually 0.13%, less than 1%, which tells you there is overwhelming evidence that H1 is true. So you can conclude that the population mean is greater than 60, since we have overwhelming evidence that H1 is true. In the next part, let's roll up a little bit. B part, again, you did everything correctly. That's 2, which is correct. And since it's the same alternative hypothesis, which is greater than 60, we write this as greater than 2.0, which is the proper way to do it. So you're looking for the probability that z is greater than 2, which is our t-stat, our z-stat, and that is not our p-value. Nope. This is the right answer. This is not the right answer because, again, as you've drawn correctly, if that's 2, greater than 2 is here, right? Greater than 2 is here. So that is going to be your p-value in here, right? So the table in the textbook and the one on Blackboard that I've given you gives you all of the area from the far left up to the z-stat, the standard z-score that you're looking for. So when you look up 2.0, what you're given is actually, if you looked up that properly, which I think you have, it's 0.9772 here. Okay, so if that's 0.9772, You're not looking for that part though. You're looking for the red part. So all of this is 100% or 1. So the p-value is equal to the probability that z is greater than 2.0. So greater than 2.0 is the red part here, right? So to calculate that red part from what we have in the table, it's 100% minus 97.72%, or point, since we're dealing decimals, 9772. So this is the p-value, 0.0220, or 2.20%, which is between 1 and 5%, which means that there is very strong evidence that H1 is true. So again, you can conclude that the population mean, mu, seems to be, there's enough evidence to infer that it is greater than 60 again. Your question before was, your question is, why, oops, the question on 1114, the hypothesis is this. Hypothesis is mu equal to 200 and mu less than 200. And the reason you don't subtract from 1 here is because our table, and it depends on what table you use. Our tables use everything, the entire normal curve. Some tables are only half, so it's just a bit of geometry. Less than 200. So in other words, whatever your t-stat was, which I didn't calculate it, but I assume you got it somewhere over here, right? Your t-stat is, let's see, your p-value is equal to the probability that z is less than, right? They have to match. Less than whatever you calculated, which I didn't calculate for you right now. Less than that. So less than this z is the red region I'm shading here, which is what you're looking for, which is the p-value. Okay? In this case, again, this is 100%, or 1. So when you look up a table for this z, the table already gives you this area because the areas on the table roll in from the left, right? And you can see that from the little diagram at the top of every table. It rolls in from the left. So this area, this red shaded region, is actually the area that is given on the table. So there's no need to subtract it from 1. It is what it is, because that's the area. So if it's greater than, it's on this side, but you have to subtract it from 1 to get the other leg, right, the other tail. But since this tail is already rolling in from the left, and this is the area that's given to you in the table, there is no need to subtract. I hope that answers your question. It's very important. Some tables, by the way, only give you, and some of the questions in my notes, because I did them with my own notes, I use other tables. Some of those questions only give you areas on the right side, starting from here and rolling in. So it really doesn't matter. It's just basically you got to know a little geometry. In this case, right, if you're looking for this side, then that table you'll have to subtract it from 0.5 instead of subtracting it from 1. And if it's on this side, then you just read it from the table. But don't worry about that. I don't want to confuse you. But I'm just letting you know that there are different types of tables out there. And in this table, since we use the entire table, right, you're rolling in from here all the way to the right. And that's why on this table, you'll see everything from 0.0 something from here up to almost 1.99998. Okay? And that's the table we use. So if it's on this side, no need to subtract because that's the area given to you in the table. If it's on this side, then on this side, if you're looking for the green part here, then in the tables that we use, the area is already given, all this area is given. All right, so you have to subtract it from 1 to get that. And is that clearer? I hope.